Good morning dear learners. I am Dr. Poddar, faculty of Bhila Institute of Technology, Durg. I welcome you all. Today in this lecture session, we will learn about challenges and future trends in mobile communication. Today we are living in the age of wireless communication, and mobile communication is the key player of this wireless communication world. The field of mobile communication is rapidly evolving, bringing both opportunities and challenges. As demand for faster and more reliable connectivity grows, the industry faces several hurdles, including spectrum scarcity, energy efficiency and security concerns. Additionally, the deployment of 5G technology introduces new complexity in the network management and infrastructure deployment. Despite these challenges, future trends in mobile communication are promising. Innovation such as Internet of Things, artificial intelligence and advanced wireless technologies are set to revolutionize how we connect and interact. Mobile communication is one of the fastest growing field, with new advancement constantly emerging. A cellular network, also known as mobile network, consists of land areas called cells, each covered by a transceiver or base station, that is abbreviated as BTS. These cells use different frequency from their neighbors to avoid interference, that is abbreviated as ACI, and ensure reliable bandwidth within each cell. This setup allows for seamless communication as users move from one cell to another, ensuring continuous connectivity. Cellular networks have revolutionized communication by enabling mobile phones to connect to the network from almost anywhere. This has led to widespread adoption and the development of various applications, including mobile internet, GPS, emergency services. This continuous innovation in this field promises even faster and more reliable communication in future, supporting a wide range of activities from personal communication to critical infrastructure. Now, to summarize what we have discussed, let us remember that the objective of mobile communication is abbreviated as C&C. That means to improve coverage, that is we have to make coverage larger and larger, and to improve capacity, that means we want to make capacity more or more to serve the more number of peoples. To achieve this objective, the technique that used is FR, that is frequency reuse. So, due to use of this FR technique, mobile communication becomes cellular communication. So, let us remember that one cell, that means one tower, that means one BTS, and that means it is the basic building block of our mobile network architecture. We will keep in the mind that main issues of mobile communication are adjacent channel interference and co-channel interference. The mobile communication we need to properly tackle, that is channel assignment strategies and handoff or handover management. With this we will move ahead. The main challenges that occurred in mobile communications are interference in data transmission, low bandwidth, regulation and spectrum, high delay, large delay variation and vulnerable to security issues. Let us discuss in detail the interference in data transmission. EMI. EMI due to external source. EMI can originate from the various external sources such as power line, machinery and other electronic devices operating on similar frequencies. Another source of EMI is internal source. Within mobile devices, component like display, processor and radios can generate EMI, affecting nearby component and antennas. Next, interference is co-channel interference, abbreviated as CCI. It occurs when multiple devices or signals operate on same frequency. Co-channel interference reduces signal quality and throughput, leading to dropped call, slower data speed and degraded service reliability. Then another is adjacent channel interference, when signal from adjacent frequency channels bleed into each other due to inadequate frequency isolation. This interference can disrupt communication quality, especially in densely populated areas where multiple networks operate closely. Multipath interference caused by signal reflection, refraction and diffraction as signal bounce back of opticals such as building, trees or terrain. Second, multipath interference results in signal fading, where multiple delayed copies of signal arrives at the receiver are out of phase, that reducing the signal strength and clarity. Intermodulation interference. Intermodulation interference occurs when signals from different frequency mix and produce unwanted signals at frequencies that are interfere with the desired communication channel. This phenomena is more common in environments with high signal power levels or when multiple transmitters are closely spaced. Weather interference. Adverse weather conditions such as rain, snow, fog and atmospheric disturbances can cause attenuate or scattered radio signal, leading to reduced signal strength and the quality. Weather interference is particularly problematic for higher frequency band used in some mobile communication systems. Then another one is man-made interference. International interference caused by malicious activity like jamming, where signals are deliberately disrupt using noise or strong interference. Jammings are somewhere required for certain confidential or security works. Unintentional interference can also occur from electronic devices not designed to comply with the electromagnetic compatibility that stands as EMC standards. Mitigating these interference challenges requires advanced signal processing techniques, improved antenna design, frequency planning and regulatory measure to manage spectrum allocation and uses efficiently. Technologies like adaptive beamforming, spectrum sharing and interference cancellation algorithms are continually evolving to enhance the reliability and performance of mobile communication in the face of interference. Low bandwidth during communication has been a persistent challenge in mobile communication, impacting the speed, quality and reliability of data transmission. Here are some challenges due to low bandwidth that we will discuss. First one is slow data transfer rate. Low bandwidth restricts the rate at which data can be transmitted between devices or over networks. This results in slower downloads or uploads of files or images or videos and web pages. User experiences delay in accessing content and performing tasks, leading to frustration and reduced productivity also. Then poor quality of audio and video due to low bandwidth. Insufficient bandwidth lead to degraded audio and video quality during calls and streaming session. Audio may suffer from distortion or dropouts, while video may buffer frequently or play at lower resolution. This affects user experience, especially in multimedia application where high quality audio and video are critical. Then due to low bandwidth, impact on real time application. Real time applications such as voice calls, video conferencing, online gaming and live streaming require consistent and sufficient bandwidth to maintain smooth and uninterrupted communication. Low bandwidth results in latency, that is delay, and jitter, that is variation in delay, affecting the real time interaction and user experience. Another one due to low bandwidth is limited capacity for concurrent users. Low bandwidth constrains the number of users that can simultaneously access the network or communicate effectively. During peak hours or in densely populated area, networks may become congested, causing further slowdown and connection failures. This limitation hampers scalability and ability to support growing number of mobile subscriber and connected devices. Impact on real time application. Real time application such as voice calls, video conferencing, online gaming and live streaming requires consistent and sufficient bandwidth to maintain smooth and uninterrupted communication. Low bandwidth results in latency, that is delay, and jitter, that is variation in delay, affecting real time interaction and user experiences. Then challenges in IoT and machine to machine communication. IoT, that is Internet of Things devices, and M2M, that is machine to machine communication, often operate under constrained bandwidth conditions. Low bandwidth limits the amount of data these devices can transmit and receive, impacting their functionality and efficiency also. Critical application such as remote monitoring, smart city infrastructure and industrial automation may suffer from delay or failures due to insufficient bandwidth. Challenges in regulation and spectrum management in mobile communication. Mobile communication has evolved rapidly over the years, but the journey has not been without its challenges. We have seen the journey started somewhere in 1980, where 1G is introduced. Over a period of 60 years, regulations, regulatory complexity, different countries have different regulatory frameworks for mobile communication. This variability can create challenges for global companies trying to standardize their services and product. Companies must navigate a patchwork of regulation that can include varying standards for safety, privacy and operational practice. Spectrum allocation. Regulation determine how spectrum is allocated and used. Government and regulatory bodies must balance the need of various stakeholders, including mobile operator, broadcasters and emergency services. Privacy and security. Regulations around data privacy and security are increasingly stringent. Compliance with the regulations, for example, like GDPR in Europe or CCPA in California, can be complex and costly. Companies must ensure their systems are designed to protect user data and privacy while maintaining the functionality. For example, we have taken GDPR. GDPR stands for General Data Protection Regulation, a law in the European Union aimed to safeguarding the data and privacy of European Union resident, and CCPA, that stands for California Consumer Privacy Act, which is a law in the United States specifically for protecting the data and privacy of the resident of USA. Interoperability standards, ensuring that the different system and technologies work seamlessly together can be challenging. Regulatory bodies often set standards to facilitate interoperability, but achieving consensus on these standards can be difficult, especially when multiple stakeholders are involved. Then spectrum management. Spectrum scarcity. The radio frequency spectrum is a finite resource. A mobile communication technology advances, the demand for spectrum increases. As the technology grows, we need more spectrum. Now, balancing the allocation of available spectrum among the various services and operator is a significant challenge. Frequency reuse. Efficient frequency reuse is crucial to maximize spectrum utilization, which is the key technology of our cellular communication. However, this requires careful planning to avoid interference between different networks and services. That is why the ACI, that is adjacent channel interference, and CCI, that is co-channel interference, is the real key issues of our cellular communication. Managing this balance becomes more complex with the growing number of mobile devices and networks. Technology upgrade. The transition from the older technology, that is from, for example, from 2G to 3G to newer ones, that is for example 4G to 5G, or often requires reallocating spectrum. This can be disruptive and costly for operator, as it involves both technical adjustment and the coordination with the regulatory authorities. Then cross border coordination. Spectrum is not confined to the national borders. Coordinating spectrum uses across countries can be challenging, especially in regions where countries have different regulation or spectrum management practices. International bodies like ITU, International Telecommunication Union, work to address these issues, but achieving global consensus can be difficult one. Addressing these challenges require ongoing collaboration between regulator, industry stakeholder and international organization to create effective policies and practices that supports the growth and innovation in mobile communication. High delay and large delay variation in mobile communication are critical issues that can significantly impact the quality and efficiency of mobile networks. Let us see the details of these challenges, that is due to delay. One is high delays, that is called latency. Let us try to define high delay or latency. This refers to the time it takes for data to travel from the source to the destination. In mobile communication, this delay can affect applications such as voice call, video streaming, online gaming and real time services. As we must remember that a 300 millisecond delay is inherent in satellite communication. So, all the effort that we need to put is to maintain that delay up to 300 only, that which we cannot avoid. The challenges is network congestion. Higher user density or network congestion can lead to increased latency, as the data packets have to wait longer to be transmitted or processed. Distance to base station. The physical distance between the user and the base station impact latency. Greater distance, especially in rural or undeserved areas, can increase delays. Signal processing. Complex signal processing required for tasks such as modulation, encoding, decoding can introduce additional delay. As the network evolves, for example, that we are moving from 4G to 5G, the processing capability must keep pace to minimize latency. The next one is routing and switching. Inefficiencies in the network routing and switching can cause delays. For instance, data may have to travel through multiple intermediate nodes or cross various network segments, each adding its own processing time. Then backhaul connectivity. The backhaul network, that is the connection between base station and the core network, can be a bottleneck. If the backhaul is slow or overloaded, it contributes to higher overall latency. The impact of this backhaul connectivity is that user experiences high latency can degrade the user experience, causing issues like lag in gaming, delays in video call and buffering in streaming services. The challenges is network loading balancing. The fluctuation in network load can cause jitter. For instance, if network traffic is unevenly distributed or if there are sudden spikes in the data transmission, jitter can increase. Packet loss and retransmissions. Packet loss and subsequent retransmission can contribute to jitter. When packets are lost, they need to be retransmitted and this can be disrupt the smooth flow of data. Variable path condition. Data packets might travel over different routes through the network and the conditions of these routes can vary, leading to inconsistency in delay. Interference. Wireless networks are susceptible to interference from various sources, including other wireless devices, environmental factor and physical obstruction. Interference can cause packet delay and contribute to jitter. The impact of this is on the quality of service, that is abbreviated as QoS or GoS. Jitter can negatively affect QoS, particularly for applications like VoIP, that is voice over internet, or video conferencing, where timing is critical for maintaining quality and clarity. User experience. Application with high jitter can experience problem like choppy audio or video dropped call and uneven data transmission or leading to a poor user experience. Mitigation strategies. Network optimization. Implementing the quality of service mechanism to prioritize critical traffic and manage resource effectively, optimizing routing algorithm to reduce unnecessary delay and avoid congestion. Advanced technology adopting 5G or coming 6G. Other advanced technology that offer reduced latency and better handling of high traffic load. Using edge computing to process data closer to user, reducing the time data spent traveling across the networks. When comparing the current and the past performance of wireless mobile communication, that the journey starts from first generation and now it is moving towards the sixth generation. The persistent issues such as poor coverage, inadequate interconnectivity, lack of flexibility and subpar quality of service have remained unresolved still. However, the forthcoming fifth generation and sixth generation technology promises to fundamentally transform the landscape of wireless communication. 5G especially is poised to introduce revolutionary features and services that will significantly shrink the global community. It aims to enhance connectivity across diverse fields, fostering advancement in mobile communication, nanotechnology, cloud computing and internet services. Unlike simply increasing bandwidth, 5G emphasizes optimizing existing bandwidth through innovative network design. One of the critical advancement in 5G technology, where we call the real wireless world, is integration of more intelligent network management modules. Cognitive software is expected to streamline tasks such as radio resource scheduling, making the management of network more efficient and effective. In essence, 5G represents a leap forward in wireless communication, addressing long standing challenges while paving the way for enhanced global connectivity and the realization of future technological concepts. Some of the future trends in mobile communication: 5G expansion and 6G deployment. Now, we are on the verge of 6th generation. Widespread 5G deployment continued global rollout of 5G network offering enhanced speed, lower latency and greater connectivity. 6G research and prototyping. Initiation of research and deployment of 6G focusing on terabit per second speed, ultra low latency and advanced AI integration is the key features of 6G. Then IoT proliferation. Massive IoT connectivity increases in the number of connected devices including smart home gadgets, wearable and industrial sensors. IoT specific networks. Development of networks tailored for IoT such as narrowband IoT and LTE-M to support low power wide area communication. AI driven network management. Use of AI and machine learning for dynamic network optimization, predictive maintenance and enhanced security. Then Edge AI, deployment of AI capability at the edge of network for real time data processing and decision making. Then enhanced mobile broadband is another future trend in mobile communication, that augmented and virtual reality, increased use of AR and VR applications for entertainment, education and remote work. Then ultra high definition UHD content, the growth in streaming UHD and 4K/8K video content requiring higher bandwidth and faster speed. Another future trend of mobile communication is smart city and infrastructure. Connected infrastructure, integration of mobile communication into smart cities infrastructure including traffic management, public safety and environmental monitoring. Then public Wi-Fi expansion, expansion of public Wi-Fi network to support seamless connectivity in urban areas. Another future trend is advanced security protocol, right. Quantum resistant encryption, the development of encryption technique to protect against potential threat from quantum computing. And another one is enhanced privacy measures, implementation of strong privacy protection and data security measures to safeguard user information. Then another future trend is network slicing, in that customized network slice and resource allocation. Customized network slices, that is creation of virtual network slice tailored to specific use cases such as IoT, critical communication and enhanced mobile broadband. Resource allocation, efficient allocation of network resource to ensure optimal performance for different application and services. Then another future trend is energy efficiency and sustainability. These are for green network and renewable energy integration. In green network, implementation of energy efficient technologies and practices to reduce the environmental impact of mobile network. And renewable energy integration, that is the use of renewable energy sources to power mobile communication infrastructure. Another trend, future trend in mobile communication is satellite and aerial network, in that LEO, low earth orbit satellite, deployment of LEO satellite constellation to provide global coverage and connectivity especially in remote and undeserved areas. Aerial platform, use of drones and high altitude platform for temporary and emergency network coverage. Another trend is enhanced user experience, seamless connectivity and personalized services. In seamless connectivity, it is expected ensuring uninterrupted connectivity and seamless user experience across the different network. And in personalized services, it is expected it offering a personalized and context aware services based on the user preference and behavior. Then another trend is emerging business models, in that network as a service and innovation application. In network as a service, offering network infrastructure and services on subscription or pay as you go basis. Innovative application, development of new application and services leveraging advanced mobile communication capabilities such as remote healthcare, autonomous vehicle and smart manufacturing. These trends highlights the dynamic and evolving nature of mobile communication driven by technological advancement and increasing demand for connectivity and services. In short, in single line I can say that we are on the verge of welcoming 6G. That we will remember our journey of first generation started from 1980, then in 1990 we got the second generation, in 2000 we got the third generation, in 2010 onwards we got the fourth generation, in 2020 onwards we got the fifth generation mobile, and from 2030 onwards we will be using sixth generation. So, in this lecture we have discussed about the challenges of mobile communication and the future trends of mobile communication. The journey span of this mobile communication is around 60 years. Every decade there is a new generation mobile that we have got it. I hope this lecture session you have attended, you understood the challenges and the future trends of mobile communication. So, I thank you all for your patience listening and attending this lecture session. Thank you one and all.